Good morning, students. Today we are going to discuss another topic of theory of machine, and that is flywheel. So today we will study that what is flywheel, what are the applications of flywheel, and where we use this flywheel, and what are the effects of this flywheel through turning moment diagram. Also we will discuss today. So let's start with the definition that what is flywheel. So now coming back to the definition of flywheel. A flywheel is like a reservoir which stores energy during the period when the supply of energy is more than the requirement and releases it during the period when the requirement of energy is more than supply. So in basic terms we can say that a flywheel like a storage tank or storage area in which when the supply is less and the requirement is more, that time flywheel supplied the extra amount of required energy to the system. And when the requirement is less but the supply is more, then it preserves the extra amount of fuel or energy to itself. That means it simply acts like a storage tank which normally stores the excess energy when it is not required, and it delivers the extra amount of energy when it is in requirement. This is simple terms. We can also go through the flywheel through a practical example. Let me provide you that so that you can understand well what is flywheel. Let us take a practical example for flywheel. We all know that in IC engine we have four processes, that is suction, compression, power and exhaust. So this last one will be the exhaust stroke. So we have four stroke, but we all know that in above four stroke, if we consider a four stroke engine, then during this four stroke, only during power stroke power is being produced, and during suction, compression or exhaust stroke there are no power which is going to be developed during these strokes. So then how the engine is running in these three strokes? So in this case the flywheel plays a major role. How that during power stroke whatsoever be the amount of power that is being developed, that is being stored in the flywheel, and during other stroke, that is suction, compression and exhaust, as during these three strokes no power is being developed, hence the power being developed during power stroke being stored in a flywheel and it is being delivered during other three strokes in the amount as per the requirements. That means simply I can say in a simple language that flywheel stores the energy when it is not required and flywheel delivers the energy when it is required. Simply I am also repeating this one once again, that is we all know that in a four-stroke IC engine, we have four processes. That is, first one is suction, compression, power and exhaust. And you all know that during these four-stroke or four processes, only during power stroke, power is developed. So we obviously have a question that how the engine is running during other three strokes. So during other three strokes the power is being developed in power strokes being circulated by the help of flywheel. I hope you understand this one. I can take another example, that is uphill and downhill. So what is this uphill and downhill? As we all know that, as I know that all of you ride a bicycle at least or a bike. If you know that if you run a motorbike, then so in motorbike while as you all know that if a engine is of capacity 10 watt, then the engine capacity will be 10 watt throughout the life of the engine. That will not vary, like the power of the engine cannot vary, like sometimes 9 watts, sometimes 8 watts, sometimes 11 watts, sometimes 12 watts. That is not possible. If engine is having a capacity of 10 watt of power or 10 HP of power, then it will be constant throughout its lifespan. So all you know that during any uphill road we have to use maximum power. That means in certain areas, as you all ride bike, you should have know that you just change the shift the gear downwards and you accelerate more while running through uphill. But while running through downhill, we simply press the clutch and we don't have to put any type of accelerator. The bike or the motorcycle automatically run away. So how the power, that means while going through downhill, we don't require any excess amount of power or any amount of power. So during that time, flywheel store the excess amount of power, and that power is being used by the motorcycle or by the flywheel while we go through uphill portion. Simply, in all conclusion, we can say that flywheel stores the amount of energy when the engine does not require it. But if there is no sufficient amount of energy and engine is required that amount of energy, then that time flywheels provides that energy. This is what flywheel is. Another important point about flywheel is that when the flywheel absorbs energy, its speed increases. That means when it is absorbing energy from the output source or from the power source, the speed of the flywheel increases, and when it releases energy, at that time the speed decreases. So through this fact we can assume that hence a flywheel does not maintain a constant speed, it simply reduces the fluctuation of speed. So you can conclude from the above point that flywheel does not maintain a constant speed, it simply reduces the fluctuation of speed. So another term that comes into the previous topic, that is fluctuation of speed. So we should know what is fluctuation of speed or what is coefficient of fluctuation of speed. So it is defined as the ratio of the maximum fluctuation of speed to the mean speed. That is called coefficient of fluctuation of speed. So the ratio of maximum fluctuation of speed to the mean speed is generally known as coefficient of fluctuation of speed, and it is denoted by C in suffix S. So we know that maximum fluctuation of speed will be n1 minus n2 and the mean speed will be n1 plus n2 by 2. So what is n1 and n2? Here n1 and n2 are maximum and minimum speed in RPM during each cycle. So n1 and n2 will be the maximum and minimum speed of the that is accumulated in RPM during each cycle. So according to the definition, we know that the coefficient of fluctuation will be the ratio of fluctuation of speed to the mean speed. So n1 minus n2 whole divided by n1 plus n2 by 2. We can rewrite this as 2 into n1 minus n2 by n1 plus n2. So this is in terms of speed. So if we write this in terms of angular speed or angular velocity, then we can write it that 2 into omega 1 minus omega 2 into omega 1 plus omega 2. Simply write where n1 and n1 n2, simply write there omega 1 omega 2. Just replace that, nothing more. And if we write in terms of linear velocity, then we can write it as 2 into v1 minus v2 into v1 plus v2. So this is simply what is all about coefficient of fluctuation of speed. So now what is the significance of coefficient of fluctuation of speed? So we'll know what is the significance next. So the actual significance of coefficient of fluctuation of speed is that CS is a limiting factor in the design of flywheel, and it varies depending upon the nature of service to which the flywheel is employed. Actually, it is a limiting factor. That means it is the main factor which is limited to flywheel. That means the design of flywheel, or in which type of engine it is being employed, what are the properties of materials being used for the manufacturing of flywheel. All these properties depends, and in which the coefficient of fluctuation of speed is the main limiting factor. Now coming to the topic, that is coefficient of fluctuation of energy, and it is denoted by CE. and E is written as suffix. So the definition of coefficient of fluctuation of energy is that it is defined as the ratio of the maximum fluctuation of energy to the work done per cycle. So mathematically it can be written as CE equals to EF minus EI divided by W. So EF minus EI is what? EF minus EI is the maximum fluctuation of energy, and where W is work done per cycle. Where EF minus EI are, EF and EI are the energy at final and initial condition respectively. So we can easily get the values of EF and EI. So now the main condition that how we will calculate the work done per cycle, that is W. So we have two different formulas through which we can calculate the W. If we have given the T mean or we have given the power or anything, we can use the formula T mean into theta, where theta is the angle in radian and which will be taken as 2 pi for 2-stroke engines, and that will be taken as 4 pi for 4-stroke engines. And to calculate the T mean, we have another formula, that is P into 60 by 2 pi n, where P is power and n is speed of engine in RPM. Now we can calculate W, that is work done per cycle, through another formula, and that is we can use this as P into 60 by n, where P is power and small n is number of working strokes per minute, which will be taken as n for 2-stroke engines and will be taken as n by 2 for 4-stroke engines. So this is all about coefficient of fluctuation of energy. Now we will get back to the topic, that is turning moment. Basically, turning moment is a diagram between it is a graph being plotted between crank effort and fluctuation of speeds, which we will get back in the next class. So thank you.